Hello everybody, welcome to Chapter 6, Section 2, entitled Adding and Subtracting Polynomials. So today guys, we're going to again talk more about polynomials, but we're actually going to take polynomials and we're going to add and subtract them. So we're going to basically be combining polynomials to make one polynomial. So if you recall yesterday, 6.1, we talked about a lot of new terms, and I'm going to be using some of those terms again today when we discuss and look at these different polynomials and adding and subtracting them. So if we can recall from yesterday, we talked about the word terms, and if we remember, a term is in the form ax to the k power. So like terms are terms that contain the same variables with the same exponents. So we should all be familiar with this this term, no pun intended, like terms. We should have discussed like terms in middle school. Okay, again, like terms are terms that contain the same variables with the same exponents. Okay, now this is very important because when we go to add and subtract polynomials, we will be combining like terms. And we've already done that this year, guys. We've combined like terms when we're solving equations, so we should be familiar with this. So looking at example 1, it says to determine whether the following are like terms or not. If not, explain why. So if we look at A, 3x and 5x, both of those terms have a single variable, x, that is raised to the same power of 1. So these are, in fact, like terms. Looking at B, we have y and negative 3y. Now, I will point out, guys, if we go back to this general term that I wrote here, ax to the k, it doesn't always have to be x. As we saw in 6.1, we started right off with a polynomial that had m's in it. And what we're going to see later on in this chapter is that some terms have multiple variables with them. So it doesn't necessarily have to be x. As we can see in B, we have y's. So we have y and negative 3y. So are these like terms? Well, they both have one single variable of y, and both of those y's are to the same power of 1. So these are, in fact, like terms. Looking at C, we have 4x and 5y, and these guys clearly are not like terms because they have different variables. They have different variables. One has an x and one has a y. Let's slide this down here. So, looking at D, so this is the one that oftentimes we see a lot of students get confused on, and we actually see students try to combine these. 2x and x squared, yes, they do both have an x, that is true. However, the term 2x has a degree of 1, while the term x squared has a degree of 2. So these are not like terms because they have different degrees or different powers. So remember, guys, like terms, they must have the same variable or variables with the same exact degrees. So let's get right into adding polynomials. Now, guys, when we add polynomials, we can only combine together the like terms. So only like terms can be combined together. Now, as we go and we add these polynomials, I will be bringing up some terms that we talked about in section 1. monomial, binomial, trinomial, etc., etc. So be prepared for me to use those terms as we proceed. So if we look at example 2 says to simplify. And guys, whenever we see simplify, that typically means to perform the operations indicated and combine like terms. So if we look here, we have 5a plus 3b plus 2a plus b. Now, you guys have heard me talk about this this year. Are the parentheses necessary in a situation where you're simply adding two things together? Well, not necessarily. However, the parentheses do indicate that we have two different polynomials. We have 5a plus 3b, and we have 2a plus b. And these are both actually binomials because they each have two terms. Now, if you do recall, our first step is actually going to be to go ahead and drop the parentheses. Remember, guys, we can only drop parentheses when there's nothing out in front of those parentheses. There's no distributive property. So once we've got rid of our parentheses, now we're going to go ahead and search for our like terms, and we're going to combine them. Now, this first process I'm going to do here, we're probably not going to do this every time, but I'm going to show you guys the long way of doing this, and I'm sure that most of you will likely just say, oh, I know what the like terms are, and just go ahead and combine them. But I'm going to go ahead and take the extra step and show you the full process. So I'm going to start here. I see 5a and 2a. So what I'm going to do is I'm going to go ahead and I'm going to get those next to each other. And I'm going to do the same thing with my 2b terms. Now, guys, what I can actually do here is I'm going to regroup these. Because what I'm going to do in this first group here, this 5a plus 2a, is I'm going to factor out an a. So if I factor out an a, so we haven't really discussed factoring a whole lot this year. However, you did do factoring in middle school. So remember, I'm dividing the a out and it's coming out front, and I'm left with 5 plus 2 on the inside. And I'm going to go ahead and I'm going to do the same thing with my second grouping. I'm going to go ahead and factor out a b. And that's going to leave me with 3 plus 1. So remember, guys, if you factor something out of itself, you always are left with a 1 there. And then what I'm going to do is, well, I'll say, okay, 5 plus 2 is 7. So that's going to give me 7a. And then over here, 3 plus 1, that's 4. So I'm going to get 4b. And there is my simplified polynomial. Now, as I said before, guys, I will not require us to do these steps here. I will not require you guys to do those steps. Most of you can probably look right here and say, okay, I see the like terms. I'm just going to do 5a plus 2a, which is 7a, and 3b plus b, which is 4b. That's what a lot of us will do. Perfectly fine. I was just going to show you guys on this first one the full mathematical method. All right, so let's jump over to b. So in b, we have 2n squared plus 3n plus 5n minus 6. Again, we are adding two binomials here. Now, since it's addition and there's nothing in front of the parentheses, I'm going to go ahead and I'm going to drop the parentheses. And I'm going to go ahead and look for like terms. Now, a neat little method that you guys can do here is, so what I usually suggest is starting with the highest power. So in this case, I have a term with a squared, or a power of 2, 2n squared. Now, if I look throughout this, I don't see any other n squareds. So that means I have no other like terms with 2n squared, so that's going to be its own term. There's nothing to add to that. Now, I'm going to move on to the next degree below that, which is 1. I'm going to go ahead and I'm going to use a different shape for that. So I might use a triangle. So I've got plus 3n, and I've got plus 5n. Those are like terms because they both have a variable of n with a degree of 1. And then I have this constant down here, which has no variable with it, and it is the only constant there is. So I'm going to circle that. So some of you guys may choose to do this. So I've got 1 square, which is my 2n squared, and there's no other square, so there's nothing to combine with that. I've got 2 triangles. One has a positive 3n in it, one has a positive 5n in it, so that is going to be a positive 8n. And then I have 1 circle, which is just my constant, which there's no other circles, so I'm simply going to bring it down. And as you guys can see here, I'm left with a trinomial of degree 2. All right, so this is a trinomial of degree 2. So in this case, when I added 2 binomials, I got a trinomial with degree 2. Now, what we're going to see really quickly, guys, is that just because you add 2 binomials together doesn't mean you're necessarily going to get a binomial back. It doesn't necessarily mean that you're going to get a trinomial. It all depends on the degree of the terms within each binomial. So in this case, we added 2 binomials and ended up with a trinomial. Whereas in the last example, we had 2 binomials and we ended up with another binomial. So it all depends on the degree of the terms. So if we jump down to C, again, the first thing I'm going to do is drop the parentheses because there is nothing to distribute. So I've got myself a trinomial, 2m squared minus 5m plus 6. And to that, I'm adding another trinomial, m squared minus m minus 5. Now, I like to show you guys a lot of different ways that you can approach this. So another maybe a little bit easier way for those of us that are really good at adding and subtracting in our head is what we can do is we can start with the highest power, which is 2. And I can say, okay, 2m squared, I'm going to cross that out, and m squared. I know that those add to 3m squared. 2m squared plus m squared is 3m squared. Now, why am I crossing them out? Because I know I've used them. I know that I've combined them, so I'm crossing them out to tell me that when I'm done, I haven't forgotten anything. So now I'm going to jump to the next power below, which is the power of 1. So I've got a negative 5m and a negative 1m. So that's going to make a negative 6m. And again, I cross those out as I go to show that I've used those. And then finally, I've got 2 constants. I've got 6 and negative 5, and 6 plus a negative 5 is a positive 1. So here I'm left with a trinomial of degree 2. So in this case we had 2 trinomials, both of degree 2, that we added together, and we ended up getting another trinomial of degree 2. All right. So let's finish up here with example D. Okay, guys, so first thing, we're going to drop. So I'm going to kind of go with the original method. I'm going to get the like terms next to each other. So I'm going to do a little bit of rearranging here. So this one's a little weird because I have multiple variables. So I'm not necessarily looking at the powers here. I'm kind of focusing on the variables. So I see that I have a 5x and a negative 5x. So what I'm going to do is I'm just going to write those next to each other. Now, if you guys are going to rearrange terms, please do not forget that the sign has to follow the term. So that negative has to follow that negative 5x. Then I have a negative 2y and a positive 2y. So minus 2y plus 2y. And what we're actually going to see here is that 5x minus 5x, that's 0. And negative 2y plus 2y, that is 0. So we actually just end up, guys, with 0. So you actually can add together two polynomials and get 0. Now, how does that happen? Well, it must have been that the two polynomials that we added together were exact opposites of one another, which, if we look back here, we can see that we had 5x minus 2y and 2y minus 5x. Those are, in fact, opposites, so they are going to cancel out, and we are going to be left with 0. Now, believe it or not, this 0 here is actually, this is a monomial. And you might say, well, what's the degree on that? Well, this is actually 0 times x to the 0. So this is degree 0. Kind of weird to say, but it is the correct mathematical terminology for 0. So it is a monomial because it's one term and its degree is 0. So I'm sure that most of you are going to say, oh yeah, adding polynomials is fairly simple. You know, you drop the parentheses if there's nothing in front of them and just go ahead and combine like terms. And I wouldn't disagree with you. However, where it does become a little bit more complicated is when we start subtracting polynomials. So, subtracting means adding the opposite of the second expression. So we are going to be adding an extra step in here, guys, when we go ahead and subtract polynomials. And it's very, very important that we pay attention to this extra step that I'm going to be adding in here, because a lot of times we forget it, and it does affect our answer. So if we look at example 3, it says simplify, and if we look at A, we have 5x plus 3 minus 2x minus 4. So we have a binomial minus a binomial. Now, guys, the first thing we're going to do here, because we're not adding, we're subtracting, recall that there's actually a negative 1 in front of this 2x minus 4. So the first thing we're going to do is we are going to distribute the negative 1 through that polynomial. And what that's going to give us, and as it says over here, that's going to give us the opposite of that original binomial. So instead of 2x minus 4, it's now going to be negative 2x plus 4. Now here's the great thing, guys. Once you take care of that extra step, it's simply combining like terms. So I've got a 5x and a negative 2x, which is going to give me 3x. And then I've got a positive 3 and a positive 4, which gives me a positive 7. So I want with the strikeout technique, and I personally like the strikeout technique because I can look back here and I see that I've crossed out all my terms, so I know that I've used them all. I know that I've used them all. So really, guys, any of those three techniques I showed you on the last slide, they're all great techniques. And some of you might just go ahead and just mentally go through and add up. I warn you to be careful so that you don't forget a term, which is why I like the strikeout technique. Okay, going over to B. Again, we have a binomial minus a binomial. Again, I've got this negative 1 in front. I'm going to go ahead and distribute. So it gives me negative 3y plus 1 minus y minus 5. Remember, it's going to have the opposite effect. So then I've got a negative 3y and a negative y, which gives me a negative 4y. And I have a positive 1 and a negative 5. And 1 minus 5 is negative 4, which leaves me with negative 4y minus 4. Again, guys, remember, all we're doing is adding that extra step of distribution, and then it's back to combining like terms. So now we have a little bit more here. We have two trinomials. So we've got z squared minus 3z plus 5 minus 4z squared minus 2z minus 1. Again, I've got this negative 1 here that I have to distribute through. That's going to leave me with z squared minus 3z plus 5. And you guys might have heard me say earlier this year that remember when we distribute a negative, it switches all the signs or makes it opposite. So we're going to get negative 4z squared plus 2z plus 1. Again, I'm going to go ahead with the strikeout technique. So I've got z squared and a negative 4z squared. So z squared minus 4z squared is negative 3z squared. Then I've got negative 3z plus 2z, which is just negative 1z. And then I've got positive 5 and a positive 1, which is going to give me a positive 6. So I'm left with a degree 2 trinomial. A degree 2 trinomial. Oh, let me undo that. Give me 1 second, guys. Hey, we're back here. So, jumping down to exercise number 4. Now, this is where the subtraction gets a little bit more difficult because it's almost like a word problem. And what you guys are going to see here is I'm going to talk about the mistake that is often made with these. So if we look at example 4, it says subtract. So if we look at A, it says from 3a minus 2, subtract 5a plus 1. Now, what I really suggest, guys, is if you're not really sure how to set these up, instead of the binomials or the polynomials there, picture numbers instead. So just for a quick second here, if I were to get rid of these, and I were just to say from 10 subtract 2, most of us will just be like, oh yeah, that's 10 minus 2. Pretty simple. Now, with that same thought process, let's think of it with the polynomials there instead. From 3a minus 2, subtract 5a plus 1. So I'm going to take 3a minus 2, and from it, I'm going to subtract 5a plus 1. Now, you guys can see that I included those parentheses. They're very important because we are going to have to distribute, again, this negative 1 through. So that's going to give us 3a minus 2 minus 5a minus 1. And then we are going to go right ahead and combine like terms. So we've got 3a minus 5a, which gives us a negative 2a. And then we've got negative 2 minus 1, which gives us a negative 3. So we end up with a binomial there, negative 2a minus 3. So looking at B, a little bit different here. It says subtract m squared plus 7m minus 1 from m squared minus 3m plus 5. Again, guys, if you are confused, just replace them with numbers. So, I don't know, 7 and 3. Subtract 7 from 3. So from 3, so I'm going to start with 3, I'm going to subtract 7. So now that we know the order it's supposed to be in, replace those back with the polynomials. So subtract m squared plus 7m minus 1 from m squared minus 3m plus 5. So from m squared minus 3m plus 5, I'm going to subtract m squared plus 7m minus 1. So guys, the mistake that a lot of people are going to make with these is they're going to put them backwards, and what's going to happen is you're going to get the exact opposite of the answer that you should have gotten. So we're going to distribute. We're going to get m squared minus 3m plus 5 minus m squared minus 7m plus 1. Guys, please remember, please draw those distribution arrows in. That helps us remember that that negative has to go to all three terms in the trinomial. A lot of us just take it to the first term or the second term and we forget the terms after. If you draw those distribution arrows, that helps you remember. Okay, so we're going to go ahead and combine like terms. Now, I've got an m squared and a negative m squared. So those are going to cancel out. So this does happen from time to time, guys. I had 2 degree 2 polynomials that I'm subtracting. So sometimes what happens is the degree 2's will actually cancel out. So just because I started with 2 degree 2 polynomials doesn't necessarily mean that I'm going to end with a degree 2 polynomial. So in this case, those cancel. So I move on to my next highest power, which is 1. So I've got negative 3m and negative 7m, which is negative 10m. And then I've got 5 and 1, which is 6. So we end up with a degree 1 binomial. So don't say, oh, I had degree 2's on both of my polynomials. How did I end up with not a degree 2 polynomial? Well, guys, sometimes those degrees will cancel out, as they have in example B. Okay, kind of similar with C here. Subtract x squared minus 5x from 3x plus 1. So from 3x plus 1, we're going to take away x squared minus 5x. We're going to distribute. So we get negative x squared plus 5x. So my highest power here is 2. I only have one of those. It's the negative x squared. So I'm just going to go ahead and bring that down. Then I move on to the powers of 1, which is 3x and 5x. That's going to give me an 8x. And then I have my 1. Now, guys, if you haven't noticed, and I should have mentioned this earlier, I've been writing all my final polynomials in standard form. So if you recall from 6.1, standard form is when we write a polynomial in descending degree order. Now, you have seen me when I go and combine like terms, I always start with the highest degree, and this ensures me that when I go to write my final answer, it is automatically going to be in standard form. So if you always start with the highest power and combine from highest to lowest, your answer is always going to end up in standard form. So there's a lot of ways that we could be tested on this concept. If we look at example number 5, it looks like we have a little bit of geometry thrown in here. So it says find the perimeter of the triangle. So we should all be familiar with perimeter. We've already talked about it this year. Remember, it is the addition of all sides. The addition of all sides. So the perimeter for this triangle is simply going to be the addition of all the sides. So I've got 10, that's the height, plus 5x, that's the base, plus the hypotenuse. Now, pay attention here because the hypotenuse is actually a binomial. So I'm going to go ahead and put that in parentheses. Now, do I truly need the parentheses? Not necessarily, because I'm adding. However, the parentheses tell us that that 3x plus 4 represents one thing. In this case, it represents the length of the hypotenuse. Now, actually, the first thing I'm going to do, guys, is go ahead and drop those parentheses. So do we need them? Not necessarily, but they do signify one thing. And then we're just going to go ahead and combine like terms. So our highest power is 1. We've got 5x to the first and 3x to the first. That's going to give us an 8x. And then we have 10 and 4, which is going to give us a 14. So our perimeter of our triangle is 8x plus 14. Now we can't actually figure out the perimeter, guys, unless we knew the value of x. Excellent. So let's move on to example 6 here. So example 6, the Regents has actually presented questions almost identical to example number 6. So it says if r equals y squared minus y minus 9 and s equals negative 2y squared plus y minus 4, find r minus s. So they want us to figure out what r minus s is. So believe it or not, guys, we're actually going to dip into chapter 5, which is the chapter we just did on systems of equations, and we're going to do a little bit of substitution method here. So for r, I'm going to go ahead and substitute in y squared minus y minus 9 because it's equal to r. So in parentheses, because I'm making a substitution here, for r, I'm going to input y squared minus y minus 9. And then for s, I'm going to substitute in negative 2y squared plus y minus 4 because it's equal to s. So important, guys, with the parentheses. Very, very important. As we should know by now, because of this subtraction, we're going to go ahead and distribute that negative 1 through. So we're going to get y squared minus y minus 9 plus 2y squared, negative times a negative, minus y plus 4. And again, guys, once your distribution is done, it is simply combining like terms. So I'm going to start with my highest power, which is a squared. So I've got y squared and 2y squared, which gives me 3y squared. I've got negative y and negative y, which is a negative 2y. Oh, not sure why I wrote 3y cubed there. Let's change that to 3y squared. So then I had negative y and negative y, which is a negative 2y. And then I have negative 9 plus 4, which gives me negative 5. So I actually end up there with a degree 2 trinomial. A degree 2 trinomial. Excellent. Let's continue on. So, example number 7. If f of x equals 2x minus 3x squared minus 7 plus 3 minus 5x squared minus 2x squared plus 12 minus x, write an equation that defines f of x as a trinomial. Okay, so that can seem daunting, but actually, guys, all they want us to do is to somehow make f of x so that it is simply a trinomial, meaning that there's only 3 terms. So right now we actually have 3 trinomials that are making up f of x right now. So we need to get this down to a single trinomial. So we have not only addition of polynomials, we also have subtraction of polynomials. So the first thing I'm going to do is I'm going to check the front of each of my parentheses to see if there's anything I need to distribute. So there's nothing in front of the first. In front of my second, there's simply a plus or a plus 1, which I don't need to distribute a plus 1 through. But in front of my third, there's that negative 1. So I am going to distribute that negative 1 through, which is going to allow me to drop all my parentheses now on my second line. So I get f of x equals 2x minus 3x squared minus 7 plus 3 minus 5x minus 5x squared. So here comes our distribution. Minus 2x squared minus 12x plus x. Notice how we did the opposite with that last trinomial. That negative makes everything opposite. Okay. Now, guys, there's a lot of terms here, but we're just combining. We're combining like terms. Again, whatever method is easiest for you, I'm going to go with the strikeout method here. So I'm going to start with my highest power, which is 2. And I actually have 3 terms that have a power of 2. Negative 3x squared, negative 5x squared, and negative 2x squared. So if I add all those, negative 3x squared, negative 5x squared, and negative 2x squared, I'm going to get negative 10x squared. So then I move to my next highest power, which is x to the first. So I've got a 2x, a negative 5x, and a negative 12x. So 2x minus 5x minus 12x is going to give me a negative 15x. And then finally I jump, and this is why we do the strikeout method, guys, because if I look all the way down here at the end, I forgot somebody. This is why we do the strikeout method. So it's not going to be negative 15x. It's going to be negative 14x. Negative 14x. Guys, I really like the strikeout method for that reason there, because if you'll go back through and look, if you missed a term, you didn't strike it out. So you'll always catch yourself. So now I'm going to jump to my constant terms, which is simply negative 7 and a positive 3, which gives me a negative 4. So I want to make sure that I answered the question. So it told me to write an equation. So I do have an equation. There's my equal sign. That defines f of x. So they want us to keep calling this equation f of x. So that's why I continue to bring the f of x down as a trinomial. And we do have a trinomial because we have 1, 2, 3 terms. Okay, let's move on to example 8. So example 8, in each student work shown below, determine the error and make the necessary corrections. So they're telling us that each student made some type of error, and we have to determine what the student did. So Marco looks like Marco's adding 2 monomials. Marco's adding 3x squared and 5x squared, and it looks like Marco got 8x to the 4th. So I don't disagree with Marco that 3 plus 5 is 8. That looks correct. But if we look at Marco's power here, he made a very, very common mistake. Marco added the exponents. Guys, when we add like terms or subtract like terms, the power should not change. When you add or subtract like terms, the new term you get should be another like term of the 2 you started with. So if we're actually going to add 3x squared and 5x squared, I should get another term that has an x to a power of 2 in it. So this should actually be 8x squared. Now, are there times when powers can change? Yes, and we will look at that later in the chapter. Okay, so let's look at Camilla's work here. So Camilla had 2x minus 4x plus 5. So it looks like we're subtracting a binomial from a monomial. And we can almost guarantee here, guys, if we know someone made an error subtracting polynomials, that they likely did not distribute correctly. And in the case of Camilla here, she did not distribute correctly because while she did give the negative to the 4x, she forgot to multiply it to the 5 here. So if we're going to do this out correctly, Camilla should have distributed that negative throughout the entire binomial. And then she should have combined like terms. So we have 2x and negative 4x, which is negative 2x, which she did get that. She got the negative 2x. But instead of this minus 5 that she should have gotten, she got a positive 5. Very, very common mistakes, guys. Let's learn from those so that we don't make those mistakes ourselves. Okay, example 9. Your classmate completed the following problem incorrectly. Write a question that you might ask him to help him realize his error. So, we've got 3s squared t minus 11.5 s squared t plus 7 3/4 s squared t, and that is apparently equal to negative 0.75 s to the 6th t cubed. Now, the problem is telling us that our classmate has made an error, so our first thing should be to determine the error that was made. Now, if we look at all three of these terms, guys, we've got 3s squared, negative 11.5, 3s squared t, negative 11.5 s squared t, and 7 3/4 s squared t. Now, these are all, in fact, like terms. Now, these ones are a little bit different, these terms, because each term has two variables in it. However, each of the two variables have the same exact power in each term. Therefore, they are like terms. Now, the first thing we should probably check is that negative 0.75. So we might want to grab our calculator here. So if we grab our calculator, so we want to go ahead 3 minus 11.5 plus 7 3/4. So that's going to be 3 minus 11.5 plus 7 3/4. Well, guys, 7 3/4 is 7.75. And we get negative 0.75, which is what our classmate got. Now, so that's not the problem. So we can probably already guess what the problem is. It's that same error that was made by the student on the last page. If we look here, these powers are different from the like terms that we combined. So what our classmate did is they added the powers together when we should not do that, because remember, our new term should also be a like term to all the terms we added before. So what we want to do is we want to write a question that you might ask your student to help realize their error. So maybe a question we might ask is, do we add the powers when we combine like terms? And obviously the answer to that, guys, is no. So hopefully this question would allow our classmate to determine their mistake. Let's move on to our last example here, example 10. Janie writes a polynomial expression using only one variable x with degree 3. Max writes a polynomial expression using only one variable x with degree 7. What can you determine about the degree of the sum of Janie and Max's polynomials? Now, we don't actually know what Janie and Max's polynomials look like. They could be monomials, they could be binomials, they could be trinomials, they could be larger than that. All we know is that Janie has degree 3. So Janie's has degree 3 and Max has degree 7. Now, if we're going to add these two polynomials together, now guys, remember when we add polynomials, we're really just combining like terms. So we want to know what the new degree is for the new polynomial that we would get. Now, a lot of us would be quick to say 10, because a lot of us will say, oh, 7 plus 3, we just add the degrees. But guys, if we recall, the degrees shouldn't change if we're adding or combining like terms together. So then the question is, well, if the degrees aren't changing, then what's going to be our new degree? Well, guys, if you're adding two polynomials, the new polynomial should take on the highest degree. So therefore, the new polynomial will have the same degree as Max's polynomial. So part B says, well, what about the difference of the two? What about the difference? Well, guys, remember, subtracting is just adding the opposite. So we are still going to be combining like terms in the end. And again, if we're combining like terms, the degrees shouldn't change. Therefore, this 2 should have the highest degree of the, should take on the degree of the highest polynomial, which again is Max's of degree 7. I hope you guys enjoyed today's lesson. A lot of new stuff coming here. A lot of new stuff coming this chapter. Remember, if you need to, go back to 6.1 and review the terminology, because again, we're going to be using that throughout the chapter and throughout the rest of the year. Thank you.